Hello everyone and welcome to History with Led, where the show where we talk about history with your host Led. Now in this very special episode of History with Led, we're not only going to talk about history, which I know you all came here in this channel for, but we're also going to talk about one of the most interesting, if not the most interesting topics that mankind has ever discussed in its entirety of existence, which is our favorite subject, science. That's right. In this special episode, we're going to talk about some pretty basic scientific history. And what better way, excuse me, to talk about some scientific history than the most basic particle that we have ever known, which is the atom, which, as we all know, is the most basic particle in the universe, or at least that's what we know as humans. So if we're going to talk about this very elementary particle of ours, we're going to go all the way back to long before we even existed, all the way back to 400 BC with our very first proponent, Democritus. So, as we all know, Democritus is the first ever proponent of the atomic theory. Now, while a lot of people are saying that Democritus is the very first proponent of the atomic theory, what a lot of people don't know is that Democritus was actually inspired by his mentor and also the unofficial very first Greek philosopher that introduced or proposed the atomic theory, which is his mentor Leucippus. So Leucippus and Democritus proposed that if you cut a rock into very small particles, it would be cut and 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 cut into smaller pieces until it comes to a point wherein it doesn't get cut anymore, or it cannot be divided into any more smaller pieces of that rock. So as you can see, their proposed atomic particle is based more on wow, I have a very weird cough today. It's based more on the reasoning than the actual science itself. So Democritus called this state of indivisibleness as atomos, which in their language practically means indivisible. So they said that this small atomos is what makes every single thing in the planet or in the universe, and it is covered by all of these empty spaces. So of course during their time, which was 400 BC, we never really had any sort of technologies, or we never had the scientific equipment to actually test this theory. But at the time it was very debated for the lack of its scientific basis, but with regards to its logical reasoning and with regards to its technicality, it was pretty much very widely accepted towards when it comes to talking about basic chemical properties or basic. So our next proponent did not go very far from Democritus, if I remember correctly. So Democritus was 400 BC, and the next proponent is what? 1803. That's right. That's not too big of a time lapse, isn't it? So an English scientist named John Dalton has once again proposed another atomic theory, which was heavily inspired by Democritus' theory of atomos. So according to John Dalton, these atoms are these tiny solid balls. So basically, when he said that a tiny solid ball, it is one very small ball where there is no other particle. It's just this indivisible small ball. And according to his four laws, atoms are indivisible. These atoms of one element are all the same. Atoms of different elements are different, and compounds formed by combining atoms. So aside from that, Dalton is also known for his law of conservation of mass and law of proportion. So fast forward to another very minimal time lapse, very minimal. What's that? So once again, we are going to skip a couple of few years, just a couple of them, like a century, and we're going straight into 1904, where another scientist in the name of J.J. Thomson has once again introduced another major contribution to the atomic, or to the history of the atom. So according to J.J. Thomson was the very first scientist to discover the electrons. So he discovered this by discovering if this a positive particle, and according to him, that if there is a positive charge on a certain object, it would also have this negative particle with it. Although he wasn't able to check upon and look upon the positive particle, he was able to encounter the negatively charged particle, which he named electron. So fast forward to 1911, where Ernest Rutherford finally saw this positive particle, and he called it protons. And he also said that these protons can be found in this very small part of the atom, which he called the nucleus. So according to him, atoms have positively charged particles in the center, and it's also mostly space on the outer part of the atom. So this paved the way for the very first model in the atom that we have, which was the solar system model. Then we're gonna pass forward to 19. Rutherford also altered J.J. Thomson's Raisin-Bun model, which I may have forgot to mention in this video earlier, but at least now I got it, alright? So he created a second model, which was the solar system model, which was also the most popular illustration of the atom, as well, specifically for me, because I watch a lot of Jimmy Neutrons, and Jimmy Neutron has a solar system model of an atom for his t-shirt. So this is the one where there is this very small ball in the center. There are a lot of orbits surrounding the nucleus to make up the atoms, which according to Rutherford is where the electrons pass from. So he was also the one to say that the electrons move around in this certain orbit. Rutherford found this after he conducted an experiment, which was Rutherford's gold experiment. So this is also the part where when I talk about the misconception that Rutherford brought up the existence of another particle. Rutherford did not brought up the existence of another particle. Instead, he discovered the existence of this certain particle. So after Ernest Rutherford, we have James Chadwick, and James Chadwick was the one who discovered the neutrons. As we all know, it is a neutrally charged particle, and it was also the one to conclude that the neutron is found in the nucleus. After James Chadwick, we have Niels Bohr, who improved Rutherford's model, and then he was the one to propose the shell model of the atoms. Of the atoms. So he said that electrons move around the nucleus in layers or shells, which is the one of his model. So the atom is here, then it is covered by these circles, which he referred to as shells. And this shells contains all the valence electrons. So in 1932, we are now provided by Edwin Schrödinger. I may have definitely slain the pronunciation of that name, so forgive me, kind sir, with the modern view of the atom, which is the nucleus at its center, and instead of the electrons traveling across various lines or orbits or shells, he said that the electrons move around this electron cloud. So unlike electrons moving on a fixed pattern, they're scattering in this cloud of various energies and forces that they are traveling on. So this model is the one that we are using nowadays, as it is the model or the actual visualization of the atom that is already observable in our microscopes. And as for microscopy, it is already out of the scope of this video. And as far as we're all concerned, that's all that can be said for the atomic theory. So if you have any comments and suggestions, leave them down below. Smash subscribe, smash that like button, smash that notification button, and see you on the next episode.
What? You never played Tuber Simulator? You know it's fun, right? I'm not supposed to give my opinion, but give it a try, and then you can tell me if it's good or not. Not convinced yet? Okay. I'll cut you a deal. The game is available for free, and that's a great price.